There's a language that's more popular than Python and more ubiquitous than JavaScript. It's more critical to your daily life than any app on your phone, and almost nobody talks about it. Every online purchase you make, every time you do a bank transfer or write a recommendation review. This all uses one 50-year-old language that quietly holds everything together. It's called SQL, or Structured Query Language, or SQL for short, and a lot of people have never heard of it. SQL is phenomenal at keeping the world running, but it's terrible at helping us understand it. Let me explain. What if I told you that SQL started not by a programmer, but by a mathematician who was trying to sort out a mess? In 1970, an IBM researcher named Edgar Codd looked at how companies stored data and basically said, this is an absolute mess. Back then, if you wanted to retrieve information from a computer, you had to know exactly where it was stored. You then had to write custom code to retrieve it. And if anything changed, you had to rewrite the code all over again. So Codd's idea was that we should store data in tables, which consisted of rows and columns, and there should be clear relationships between them. And then he thought, well, if he can do that, he could write simple logic and the computer could figure out all the messy details. So a few years later, IBM built a system to test this idea, but they needed a language for it. So they called it Structured English Query Language, which was later shortened to SQL because of trademark issues. Anyway, the genius of SQL is that it's declarative. You don't need to tell the computer how to get your data. You tell it what you want, and the language figures out the rest. That simple idea is why SQL, 50 years later, is still with us. SQL became so popular, it became the default. And that's why almost every piece of software you use, banking, airlines, hospitals, your company's CRM, everything, they all speak SQL underneath. So how did one language become dominant? And is that a good thing? Well, there's three reasons. One, it got standardized. In the 1980s, SQL became an official standard. And that meant that different companies could build different databases, but they all use the same language underneath. Number two, it's obsessive about correctness. SQL databases follow a set of strict rules called ACID. These are foundation principles that guarantees that your data always stays accurate, complete, and trustworthy. You don't have half-finished transactions or corrupted records, ever, or you shouldn't. Number three, it grows with you. SQL added features over decades, transactions, constraints, indexes, joins, and then really more advanced stuff like window functions, common table expressions, stored procedures. It just kept evolving enough to stay relevant. For one type of question, SQL is basically unbeatable. When you need to answer questions like, what's the current price of this item? Or how much inventory of this do we have? Or transfer $500 from account A to account B and make sure it happens correctly. For that, it's not just good at this, it's legendary. But then what if someone asks a different type of question? And that's where the cracks start to appear. SQL is great at some things like transactions, but it's really terrible at other things like analytics. And that's because analytics answers a fundamentally different set of questions, such as what patterns exist across millions of customers? What would happen now if I raise the prices by 10%? Or can we predict who's next going to cancel? SQL can do some of this. Modern SQL, in fact, has gotten really quite powerful, but it feels like eating soup with a fork. Technically possible, but deeply unsatisfying. And there are four reasons for this. Number one, analytics is iterative. Machine learning, statistical modeling, optimization, they all loop. They train, test, adjust, and repeat. But SQL is set-based, which basically SQL is a transaction, and there's not a natural way that you can iterate. Number two, complex analytics becomes unreadable. If you've ever seen a 300-line SQL query with 17 nested subqueries and 5 temporary subtables, it's a mess. And nobody wants to touch it, and nobody can debug it. Number three, SQL thinks in rows, but analytics thinks in vectors. So modern analytics, especially anything touching AI, is basically linear algebra. Vectors, matrices, dot products. SQL doesn't think in those shapes. It thinks as rows and joins. Number four, performance hits a wall. Even with indexes and optimizations, SQL analytics often has to scan billions of rows aggregate everything and return one number, and that's just not efficient. So although SQL is hugely popular and it's used everywhere, it's often used for things that it's really not very good at. So what's the future of analytics if we don't use SQL at all? Well, here's where it gets really exciting. And this is at the cutting edge of computation right now, and it's dominated by one thing, matrix multiplication. GPUs, or graphics processing units, were designed to do that one thing insanely well. They take massive blocks of numbers and perform linear algebra on it really, really fast, thousands of calculations in parallel. And guess what modern AI analytics is actually under the hood? It's matrix mathematics. Embeddings, well, they're vectors. Similarity searches, well, they're dot products. Neural networks, well, they're basically layers of matrix multiplications. So a new generation of tools is emerging that skips the SQL model entirely. They represent data as vectors and matrices instead of rows and tables. They use GPU accelerations to crunch numbers in parallel instead of by transaction. So if you think about it, instead of scanning a billion rows to find patterns, you encode the data into a compressed mathematical representation and compute the answer directly. It's already happening through vector databases like Pinecone and Weaviate. SQL is undefeated for transactions. If you care about correctness, integrity, and keeping everything consistent, SQL is the best tool for that humanity's ever built. But SQL for analytics, it's not great. It's verbose. It works opposite to the shape of the problem, and you really can't leverage the hardware revolution that's happening with GPUs. So I think the next few years are going to be fascinating. We're going to see the ability to systems to blend the reliability of databases with the speed of vectorized matrix first computation. SQL will still run the transactional world, but the world of analytics, I think that's learning a whole new language, and this is going to be fascinating to watch. If you're enjoying these videos, please consider subscribing to my channel so you can be notified when the next one comes out. And thank you for all your comments, and I sincerely appreciate your feedback.